All right, welcome to our next video. In this video, we are going to be working the CSEC June 2020 paper. If you have any queries, you can send an email to real.chemist92@gmail.com. So if you have any questions, you can ask, or you can ask it in the comment section. All right, so the first question, so it's June 2020, paper 1. It says, which of the following processes provide evidence of the particulate nature of matter? This question has repeated quite a number of years. So, and you should know, so the answers provided are diffusion, filtration, and osmosis. And as you should know, the answers are diffusion and osmosis. So for number 1, 2020, the answer is diffusion and osmosis, which is B. So they gave us more than one options. So part A, it was 1 and 2, which would be diffusion and filtration. And we know filtration is not a part of it. B says 1 and 3, which is diffusion and osmosis. So the answer is B, 1 and 3. All right, so number 2, it says mass number is the number of, so we know mass number is the number of protons and neutrons. And so the answer for that is A, protons and neutrons. So number 3, it says the arrangement of electrons in atoms of X and Y are 285 and 286 respectively. Which of the following represents X and Y? So A says non-metal for both X and Y. So let me just explain about this. So if you want to know if it's a metal or a non-metal, all we need to do is pay attention to the amount of electrons on the valence shell. So for X, it was 285 for element X, and element Y, it was 286. The valence shell, if it has 1 to 3 electrons, it is a metal. All right? If it has 5 to 7 electrons, it is a non-metal. If it has 8 electrons, it is a noble gas. And if it has 4 electrons, it is a metalloid. So 5 to 7 electrons, non-metal. 1 to 3 valence electrons, it's a metal. Element X has 5 valence electrons. Element Y has 6 valence electrons. So both of them has 5 to 7 valence electrons. So both of them are non-metals. With this, there's an exception, hydrogen. It has 1 valence electron, but it's a non-metal. Carbon has 4 electrons. It's not a metallite, it's also a non-metal. And boron with 3 valence electrons is a metallite. For the 3 exceptions to this valency rule, hydrogen has 1 valence electron. It's not a metal, it's a non-metal. Carbon has 4 valence electrons. It's not a metallite, it's a non-metal. And boron with 3 valence electrons is a metallite. All right, so the answer to our question is that X and Y are non-metals. So number 3, that is A. So number 4, we are given a table. All right, so let me just put that quickly on the board. All right, so for this question, we have 4 elements, Q, R, S, and T, and we have the number of protons, electrons, and neutrons for each of them. So the first question, as it relates to this table, so we're at number 4. It says, which of the following elements is an anion? So an anion is a negative ion because that means it should have more electrons than protons. So anion is a negative ion. To get a negative ion, the atom has to gain electrons. So just look for one that has more electrons than it has protons. If you look at Q, it has 8 protons and 8 electrons. That is not an ion. An ion has unequal number of protons and electrons. Positive ions, which are the cations, they have more protons than electrons. The anion, which are your negative ions, they have more electrons than protons. If you look at R, the number of protons and electrons are also equal. If you look at S, the number of protons and electrons are equal. If you look at T, the amount of electron is greater than the amount of protons. So T is the anion because it has more electrons than protons. So it would have gained electrons. And so for number 4, the answer is D, which is corresponding to T. All right. So number 5, it says, which of the following pairs of elements are isotopes? So for question number 5, we must identify which of these pairs of elements are isotopes. So remember, for isotopes, we want 2 elements that have the same number of protons but different number of neutrons. So if you look at Q, so look for 2 elements with 8 protons. Q and S have 8 protons. Let us check the neutrons for Q and S. So both of them have the same amount of protons, but when it gets to the neutron, Q has 8 and S have 9. So the number of neutrons are different, but the number of protons is the same. So that means Q and S are isotopes. If you look at R and T, both of them have 16 protons, but both of them also have 16 neutrons. Number of neutrons is the same, number of protons is the same, so they are not isotopes. So the answer is Q and S. So for number 5, the answer is C. For number 6, it says element Q is, and the options are oxygen, chlorine, nitrogen, and sulfur. Element Q, it has 8 protons. Therefore, the atomic number is 8. And the element with an atomic number of 8 is oxygen. So for number 6, element Q is oxygen. So 6 is 8. Then it says, which of the following acids, so we're moving on to acid, bases and salts, which of the following acids will not form an acidic salt? All right. So to get an acidic salt, you need, the acid must have at least 2 hydrogens. Any acid that will donate, so any monobasic acid will form a normal salt only. The acids given will have phosphoric acid, carbonic acid, sulfuric acid, ethanoic acid. All right. So we have phosphoric acid, H3, so you can donate 3 hydrogen ions. So for phosphoric acid, let us say it is forming a salt containing sodium. You can get NaH2PO4, Na2HPO4, Na3PO4. Carbonic acid, H2CO3. So in the same manner, as long as you have more than 1 hydrogen, you can form an acidic salt. So an acidic salt is a salt that contains hydrogen. This one here, Na3PO4, that is a normal salt. It does not contain any hydrogen. So when the metal of the base replaces the hydrogen of the acid, that is how you get a salt. But because you have three hydrogens here in phosphoric acid, 1, 2, or 3 of them can be replaced. Unless you replace all 3 of them, you will get an acidic salt. Because as you can see in the first 2 salts, hydrogens are present. So you can get an acidic salt. Carbonic acid, it also has 2 hydrogens, so you can get an acidic salt. Sulfuric acid, it has 2 hydrogens, so you can get an acidic salt. However, ethanoic acid, even though you see 4 with, remember now this is an organic acid, and when it reacts, it is the hydrogen of the functional group, which is the COOH group. It is this hydrogen that will take part, all right, or that will be donated, not these hydrogens, only the hydrogen of the functional group. And this functional group only has 1 hydrogen. So it is not possible to form a salt with this acid and still retain the hydrogen. It only has 1 hydrogen. So once it gives up this 1 hydrogen, you don't have any more hydrogen remaining. So this acid, along with hydrochloric acid, which only has 1 hydrogen, it will only form a normal salt. As long as your acid has more than 1 hydrogen, it can form an acidic salt as well as a normal salt. It will form the normal salt if you replace all of the hydrogens. It will be an acidic salt if you only replace 1 hydrogen, or in this case, 2 hydrogens. So with that said, let's go back to the question 7. Which of the following acids will not form an acidic salt? So the answer is ethanoic acid. So number 7 is B. All right, number 8, it says an ion with a single negative charge may be converted into a neutral atom by, and the options: A, losing a neutron. All right, let's just get to the point. To get an ion, you have to lose electrons or gain electrons. If you lose electrons, you get a positive ion. If the atom gains electrons, you get a negative ion. In this case, it says the ion, it has a single negative charge. If the ion has a single negative charge, example chlorine, right? Let's look at chlorine. The atom of chlorine is neutral. If chlorine gains an electron, that is how you get the chloride ion with a single negative charge. The atom gains an extra electrons, that is how it gets the negative charge. So if the chloride ion should give up the electron, it will go back to being the chlorine atom. So the atom gains 1 electron, it forms an ion with a single negative charge. If that ion gives up the electron, it goes back to forming the atom. All right? So the question says, an ion with a single negative charge, right? Example, the chloride ion. Doesn't matter which ion, once it has a single negative charge. If it was 2 minus, it would have been 2 electrons. All right, so an ion with a single negative charge may be converted into a neutral atom by, and as you can see, it would have to lose 1 electron to be converted back to the atom. So the answer is the ion with the single negative charge would be converted into the neutral atom by losing an electron. Right? So losing an electron. So number 8 is C. Number 9 says which of Which of the following aqueous solutions contains 1 mole of hydrogen? All right, so continuing again, for this question, it says, which of the following aqueous solutions contains 1 mole of hydrogen ions? So which of these aqueous solutions contains 1 mole of hydrogen ions? So to start out, hydrochloric acid contains 1 hydrogen ion. So when HCl dissociate, we will get 1 hydrogen ion. Hydrochloric acid is a strong acid. So any amount of moles of HCl is present, that is the amount of moles of hydrogen. That is the amount of moles of hydrogen ions it will dissociate into. So if you have 1 mole of HCl, you will get 1 mole of hydrogen ions. That's the mole ratio. For sulfuric acid, which is a dibasic acid, if it dissociates, you will get 2 hydrogen ions. So 1 mole of sulfuric acid will generate 2 moles of hydrogen ions. Ethanoic acid is a weak acid, right? So the moles, because it is weak, it will not dissociate completely. So it will not be equal to the hydrogen ions. So like with this equation, you say 1 mole of HCl give you 1 mole of hydrogen ion, because this is a weak acid, it will not work. So automatically, ethanoic acid is out of it. Now, they give you volume and they give you the concentration. This should be concentration, right? So it's 0.5 moles per BMQ. So if you get concentration and volume, you multiply both of them and you will get the number of moles. So 2 times 0.5, that is 1 mole. 2 times 0.5, that is also 1 mole. 1 times 1, that is also 1. So in A, we have 1 mole of acid. In part B, we have 1 mole of sulfuric acid. And in C, we also have 1 mole of sulfuric acid. The answer is hydrochloric acid. Simply, let us look at the mole ratio. 1 mole of hydrochloric acid will give you 1 mole of hydrogen ion. For sulfuric acid, 1 mole of sulfuric acid will give you 2 moles of hydrogen ions. The answer to part A is 1 mole of hydrochloric acid. Therefore, we are getting 1 mole of hydrogen ion. Both B and C have 1 mole of HCl. So we have to times that by 2 to figure out how many moles of hydrogen ions would be in solution. So both B and C would give you 2 moles of hydrogen ions. And so the answer is A. Hydrochloric acid is a monobasic acid. It will only give 1 hydrogen ion. So the mole ratio is 1 to 1. For sulfuric acid, 1 mole of it gives you 2 hydrogen ions. So that is why the answer is A. All right, so the next question, number 10, says a separating funnel can be used to separate a mixture of. Separating funnel is used to separate immiscible liquids. So for A, we have water and ethanol, those are miscible. Then part B, you have water and kerosene, those are immiscible liquids. So that is their answer. So a separating funnel can be used to separate a mixture of kerosene and water. So number 9 was A, number 10 is B. Number 11 says a new element R shows chemical properties similar to the element sodium. What is the correct formula of a compound with R and sulfur? So what is the correct formula of a compound formed with R and sulfur? So remember, R is essentially sodium. Now, if it is similar to the chemical properties of sodium, sodium is in group 1. So since sodium is in group 1, we know that it has 1 valence electrons. So we can assume that R, whatever its electronic configuration is, it should have 1 electron on its valence shell. All right? And sulfur, which is 16, as 2, it would need 2 more electrons to become stable. All right? So R would form a positive ion. Sulfur, the sulfide ion is 2 minus. So if you do a simple formula, you should get R2S. R from ionic bonding, you should know that you would require 2 atoms of R to transfer 2 electrons to sulfur. 2, 4, 6. So sulfur would need to gain 2 electrons. All right? So you use 2 atoms of R. So the formula is R2S. Remember again, sodium, it shows similar chemical properties to sodium. That means it has to be in the same group as sodium. And if it is in group 1, it has 1 valence electrons. All right? Sulfur needs 2. So we need 2 atoms of R to transfer 1 electron. So the formula or the answer is R2S, which is C. So number 11 is C. All right, for number 12, it says which 2 elements above when combined with each other forms an ionic compound. So they gave us the atomic number of 4 elements. The atomic numbers are 3, 6, 17, and 18. 3, 6, 17, and 18. Electronic configuration for each of them. This is another gas. This is carbon. This is chlorine. This is lithium. The ionic compound lithium chloride can be formed. So the answer is 1 and 3. Lithium and chlorine. So the ionic compound, remember lithium is a metal, chlorine is a non-metal. So you would get lithium chloride, and so the answer is 1 and 3, which is B. So number 12 is B as in boy. All right, so next question. It gave us the melting point and the boiling point of compound X. Melting point is 18 degrees Celsius, boiling point is 55. So this compound has low melting point and low boiling point, which you know to be non-metals. So it says compound X is most likely a liquid metal, no. A giant molecule, no. C, a simple molecule. Simple molecule, those are covalent. Remember, covalent compounds form molecules, right? Not covalent compounds, sorry. Non-metals form covalent compounds. So like chlorine, HBr, right? Simple covalent molecules, they have low melting and boiling point compared to ionic compounds or metallic compounds with high melting and boiling point. So the answer here is C, a simple molecule. So number 13, compound X, a simple molecule. Answer is C. Number 14, which of the following statements best describes the formation of a metallic bond? Metallic bonds are formed between when cations are surrounded by a sea of mobile electrons. Sometimes you will see delocalized electrons. Based on that, the answer is B. B says cations are held together by a sea of mobile electrons. So 14 is B. Number 15, it says covalent compounds can be formed between A says a metal and a non-metal. That is an ionic bond right there. Says a positive ion and a negative ion. No. Positive ions are formed from metals. Remember, covalent bonds are formed from non-metals only. And then C says two identical non-metal atoms, excluding noble gases. That is correct. So chlorine and chlorine can form a bond. Two oxygen atoms can form a bond. So two identical non-metal atoms, excluding the noble gas, which we know already has 8 electrons on their valence shell. Or if it's helium, it has 2. So the answer is C. Two identical non-metal atoms. Part D, so D, it had said two identical non-metal atoms, including the noble gases. But the noble gases already have the full number of electrons, so they would not form a bond. And from number 16, it says graphite can be used as a lubricant because of a loose electron we can move through the lattice. Graphite can conduct electricity because of the mobile electrons in the structure. That is not why it is used as a lubricant. For part B is why it is used as a lubricant. It has a weak attraction among the hexagonal layers of carbon atoms. That is used as a lubricant because of the weak attractions. Okay? So number 16 is B. Number 17, it says which set of elements form molecules which can contain 2 atoms. Which set of elements form molecules which can contain 2 atoms. It basically asks which set of elements can form diatomic molecules. The answer is given A, period 2. In interest of time, it is group 7. So group 7, your halogens, fluorine, chlorine, bromine, iodine, they exist as diatomic molecules. That is F2, Cl2, Br2, I2. They are diatomic molecules. So 2 atoms of chlorine would combine, 2 atoms of bromine, 2 atoms of iodine. All right. So the answer here is C, which is group 7. Elements form molecules which contain 2 atoms, group 7. Number 18, it says which of these following halogens is a liquid at room temperature. So in group 7, the physical state, they start out with the gas, then they go to liquid, then solid. So fluorine, chlorine, gas, bromine is a liquid, iodine is a solid at room temperature. So the answer here is bromine. So number 18 is A. Which of the following halogens is a liquid at room temperature? Bromine is a liquid. Fluorine and chlorine, those are gas. And iodine is a solid. Number 19, it says in which of the following compounds does hydrogen have a negative oxidation number? So hydrogen, it always have a positive oxidation number, except when it is bonded with a metal. And the options here, A, we have CH4, carbon is not a metal. B, H2O2, oxygen is not a metal. C, we have ammonia, Na3, nitrogen is not a metal. D, we have NaH, Na for sodium, we know that sodium is a metal. As I said, hydrogen has a negative oxidation number, then -1 when it is bonded with a metal. So in this case, the answer is D, sodium hydride, NaH. For question 20, it says which of the following, when added to sulfuric acid, would be the least suitable method for preparing copper sulfate? Copper sulfate is a soluble salt. And when you want to prepare a soluble salt, you normally do an acid-base reaction, whether it's the metal oxide, the hydroxide, or the carbonate. You just mix one of those with the acid. So the options here we have copper oxide. So remember I said the oxide, the hydroxide, or the carbonate. Here for A, we have copper oxide, B, we have copper chloride, C, copper carbonate, and D, copper hydroxide. So the least suitable method for preparing copper sulfate would be to use copper chloride. And by the way, copper chloride is a mixed copper. The chloride that, as I see the name for this, copper chloride, that is not a base. I remember we said we normally use a base. So you use the oxide, the carbonate, and the hydroxide. So the answer is copper chloride, which is B. Number 20 is B. And so this question comes quite a lot. The pH of fresh sugar cane juice, which is usually 5 to 5.5, can be changed to 7.5 to 8 for efficient processing by adding, and the answer is calcium hydroxide. So this question repeats quite a lot. The answer is slate lime, which is calcium hydroxide. Right, so slate lime. Right. Then 22 says which of the following substances represented by the options A, B, C, and D in the following table is most likely to be sodium chloride. So sodium chloride has high melting and boiling point. So in the table, you are going to look for, so let me tell you the options. So they give us boiling point, data, and electrical conductivity. So ionic compounds, they have high melting point. Well, in the table, they give us boiling point, but they have high melting and boiling point. They conduct electricity in the molten state or in an aqueous solution. All right. So for A, the boiling point is 1465. For electrical conductivity, it does not conduct electricity in the solid state. And in the aqueous state, it says it conducts electricity. All right, so let me just put the table on the board. All right, so for two of the options, right, I put option A and B on the board. For A and B, if you notice, both of them says it does not conduct electricity in the solid state. So it is known for the solid state. But in aqueous solution, it does. So both of these are telling us that option A and B is an ionic compound. However, the boiling point for A is 1465 degrees Celsius. That is very high. But for B, it is minus 35. That is extremely low. So even though for B, it says it does not conduct electricity in the solid state, but it does in the aqueous state, you have to look at the boiling point. It is extremely low. That is not an ionic compound. Ionic compounds have high boiling point. So the answer is A, because it has a high boiling point, does not conduct in the solid state, but it does in the aqueous state. So for number 22, answer is B. And moving on to number 23, we have a reaction here. Which of the following compound is reduced? All right, so we have nitrogen dioxide, sulfur dioxide, You get nitrogen monoxide and sulfur trioxide. So it said, which of the following compound is reduced? Nitrogen here is in the +4 oxidation state. So remember, in calculating oxidation state, let us do it for NO2. We look if the molecule has any charge. Clearly, it does not have a charge. So, for example, the sulfate ion, it has a charge of -2. Nitrogen dioxide is NO2, it does not have a charge. So when you add the oxidation state, you should get 0. We're trying to find the oxidation state of nitrogen. Because I already know that oxygen has an oxidation state of -2. So NO2, they have 2 atoms of oxygen. It's the number of atoms times the oxidation state of the atom. 2 atoms of oxygen times the oxidation state, which is -2. I'm going to use X to represent nitrogen. So 2 times 2, -4. X minus 4 is equal to 0. X is equal to +4. When the -4 comes, we get +4. So that is why nitrogen is in the +4 state. Sulfur is also in the +4 state. Here nitrogen is +2, and sulfur is +6. Oxidation is the increase. So in terms of oxidation state, oxidation is the increase in oxidation state. Reduction is the decrease in oxidation state. If you look at nitrogen, it is decreasing from +4 to +2. That is a decrease. So NO2 equals reduced. All right. So for 23, it says which of the following compound is reduced? It is NO2. So 23 is B as in boy. Then it says which for 24, which of the following compound is the oxidizing agent? The oxidizing agent is always reduced. Reducing agent is always oxidized. So if NO2 was reduced, that makes it the oxidizing agent. So 24 is B as in boy as well. So 23 and 24 is B. For 25, it says which of the following acid is weakly ionized in aqueous solutions? We have nitric acid, ethanoic acid, sulfuric acid, and hydrochloric acid. Of those 4 acids, ethanoic acid is the only weak acid, and we know that weak acids are partially ionized. All right, so the answer here is ethanoic acid. Which of the following acids is weakly ionized? Ethanoic acid, which is a weak acid. All right, then we have an equation for, so that was 25, B as in boy. 26, which of the following statement below is true for the following equation? The equation is a reaction between magnesium sulfuric acid. So, magnesium reacts with sulfuric acid to give magnesium sulfate and hydrogen gas. Magnesium is in its standard state here, so it has an oxidation number of 0. It is in its aqueous state, that means we have magnesium ion. Magnesium is equal to 2, so it has an oxidation number of +2. The question asks, which of the following statement below is true for this reaction? Part A says magnesium is oxidized from oxidation state of 0 to +2. As you can see, that is type. Here, it is a solid, metals are solid in their standard state. So it was 0, as I explained, is in the aqueous state, which means it is in its ionic form, so +2. So it went from 0 to +2, so it was oxidized. So So the answer for 26 is A. Magnesium is oxidized from oxidation state of 0 to +2. For 27, we have a table with some tests and observation. So it says which test can be used to identify ammonia gas. So we know that ammonia gas is basic gas. If you want to identify a basic gas, you use damp red litmus paper and it will change it to blue. If you want to identify an acidic gas, you can use damp blue litmus paper and it will change it to red. So for 27, it says which test can be used to identify ammonia gas. And in the table, you have the options A, B, C, D. For C, the test says damp red litmus paper. Observation, damp red litmus paper turns blue. So that is the answer right there, C. Remember, ammonia is a basic gas, so you use red litmus paper. Remember acid change? Sorry. Ammonia is a basic gas, basis change, red litmus paper to blue. So the answer is C. You are going to use damp red litmus paper. For 28, so 27 is C, 28, which test can be used to identify an acidic gas? The answer is A, because A says damp blue litmus paper. So damp blue litmus paper is for your acidic gas. Damp red litmus paper is for your basic gas. So 27 is C, 28 is A. 29 says, which of the following occurs when a metal atom, which of the following occurs in a metal atom when it loses, which of the following occurs in a metal atom when it becomes an ion? So remember, I said earlier, metal atoms, to become an ion, they will lose electrons. So metal lose electrons to form positive ions called cations. Non-metals gain electrons to form anions. All right. So the answer, so part A says gain electrons and is oxidized, incorrect. B says gain again, it's incorrect. C says loses electrons and is oxidized, that is correct. Because we know that loss of electron is oxidation. So 29 is C. Metal atoms becomes ion when they lose electrons and is oxidized. So 29 is C. All right. 30 says on adding aqueous hydrochloric acid to a solution in a test tube, a gas is given off, which extinguishes a burning splint. Carbon dioxide, that is what is in fire extinguishers. All right, so it out the flame. So hydrochloric acid is added to a solution in a test tube. A gas is given off, which extinguishes a burning splint. This shows the presence of A, nitrate ion, B, sodium ions, C, ammonium ions, D, carbonate ions. If I just told you that it would be carbon dioxide gas, then it would have to be the carbonate ion that would have been present. When it reacts with the acid, you get carbon dioxide. So for example, if the solution was sodium carbonate, you know that carbonates and acid give a salt, carbon dioxide, and water. Right? So once you get carbon dioxide gas being given off, you know that the carbonate ion is present. So the answer for number 30 is D as in dog, carbonate ion. Right? 31. Which of the following will not conduct electricity? So to conduct electricity, we need mobile ions or mobile electrons. Remember, graphite it has mobile electrons, that is why we can use it as electrodes in electrolysis. So A says solid calcium. Solid calcium, that would have been metal atoms, metallic bonding, in metallic bonding, we said what? Cations surrounded by a sea of mobile electrons. So electrons are able to move. That means solid calcium is able to conduct electricity because mobile electrons are present in your metal. B says solid sodium chloride. We just did a question on this, right? Ionic compounds conduct electricity when molten or in solution. C says molten calcium chloride. That is correct. Calcium chloride is an ionic compound, it is molten. D says a solution of calcium chloride in water. That is also correct. So the answer here is B, solid sodium chloride. It will not conduct electricity in the solid state. Right? So what is that? 31 is B as in what? 32, an atom with atomic structure, so it has an atomic number of 13 and the mass number of 27. And so that is the atomic structure for X. It says an atom with atomic structure, this contains A, 13 protons and 14 neutrons. That is correct. Remember, the atomic number and the number of protons is the same. So the atomic number is 13, the number of protons is also 13. To get the number of neutrons, you subtract the atomic number and the mass number. So 13 from 27, that will give you 14. So the answer is A, 13 protons and 14 neutrons. So this atom has 13 protons, 14 neutrons. So 32 is A. For 33, it says, which of the following is a list of all the raw materials used in the extraction of iron? In the extraction of iron, you will need air, coke, iron ore, and limestone. So the answer for 33 is C. Air, coke, iron ore, and limestone. So 33 is C. 34 says, which of the following metals will not displace hydrogen from hydrogen? Sorry. Which of the following metals will not displace hydrogen from dilute hydrochloric acid? So to displace hydrogen from an acid, the metal must be above hydrogen in the reactivity series. Copper and silver are below hydrogen, so they will not displace hydrogen from an acid. The options here says A is zinc, B is iron, C is copper, and D is aluminum. So the answer is C, copper. So copper will not displace hydrogen. 35 says, how many coulombs of electricity? So 35, how many coulombs of electricity passes through an electrolyte when a current of 100 amperes flows for 10 minutes? So a current of 100 amperes flows for 10 minutes. So remember, Q I, which is current multiplied by time. The time must be in seconds. So time is 10 minutes. You have to times by 60 to get it into seconds. So that would be 600 seconds. Remember, the current was 100. So it is 100 times 600. We will get 60 as your answer. All right. So all they asked for was the how many coulombs of electricity, right? So it's Q is equal to I times T. The answer is 60,000. So 35 is D as in dog. So 35, D as in dog. And 36 says, which of the following gases will give a positive test with dry cobalt chloride paper? So water is, cobalt chloride is used to test for water. So the answer is the H2O. D as in dog. So cobalt chloride paper, test for water. All right. So 37, we have Reaction scheme with says the product polyethylene is A gas, B solid, C liquid, D a solution. Polyethylene is a polymer of ethylene, so it is used to make plastic and other things, right? Polyethylene is a solid. So it says the product polyethylene is A gas, B solid. So the answer is B. Polyethylene is a solid. Then it says, so that was for 37. So 37, the product polyethylene is a solid. Answer is B as in boy. 38, it says product one, all right? And product one, product one, ethylene, children, sulfuric acid, water, sulfuric acid and water. So clearly this is hydration. And if you hydrate an alkene, you must get an alcohol. So if you hydrate E3, you must get ethanol. So the answer is ethanol. So this is product one over here, which was left empty. So it was ethylene, and they gave you the concentrated sulfuric acid and water, and you are supposed to figure out what is the product here. So the product is ethanol, it is hydration. 126 alkene with sulfuric acid and water, that is hydration. All right, so for 38, the answer is ethanol, which is B as in boy. All right, 39 says, which of the following diagrams best illustrate hydrogen bonding? Sorry, best illustrates bonding in hydrogen bromide. So hydrogen, it has one valence electrons. Bromine is in group 7, so it would have 7 valence electrons. So it becomes stable. Hydrogen needs to be 1, bromine needs to be 1. So they will just share the electrons. And remember, after you show the sharing, the electrons that were shared, you put them in the intersection. So you make both circles intersect. Whatever was shared goes in the intersection. Whatever was not shared, it goes back. So 2, 4, 6. So this is HDR. Let's say which of the following diagrams best illustrate bonding in HBr? For this paper, the answer is B. All right, but that is there. As number 40, it says a solution when treated with the gas sulfur dioxide becomes green. This solution contains potassium, and then the answers. So the solution contains potassium, almost finish it. A says it's nitrate, B says it's sulfate, C says it's permanganate, D says it's dichromate. Now, this is a redox reaction. You are familiar with permanganate, which normally changes from earth to colorless, and dichromate, it changes from orange to green. So the answer here is dichromate. Right? It will have changed from orange to green when it is reduced. So 40 is B as in dog, dichromate. 41. So we have a table here, and it says which of the elements is likely to form a soluble hydroxide. Soluble hydroxide, those are group 1 metals. Group 1 metals, as we know, are very reactive. All right? And they are giving us some observations. So we have the metals W, X, Y, and Z, and they give us the reaction with water or steam. So for W, it gives no reaction with water or steam. That means it is very unreactive. X reacts with steam, but not with cold water. It's not that reactive. Y reacts rapidly with cold water. That's a group 1 metal. Group 1 metals are the only ones that reacts rapidly with cold water. So Y reacts rapidly with cold water. So Y is a group 1 metal. Z reacts slowly with cold water. All right. So if we are looking for soluble hydroxides, they are looking for one that reacts rapidly with cold water. Also, other than the reaction with water, they give us the products formed when nitrate is heated. Now for your group 1 nitrate, when it is heated, you get the metal nitride and oxygen. So if you eat sodium nitrate, you get sodium nitride and oxygen. So to go back to the question, it says which of the metal is likely to form a soluble hydroxide? The answer is Y, because for metal Y, it reacts rapidly with cold water, and when the nitrate, it decomposes into nitrite and oxygen, which is the product for group 1 metal nitrates when they decompose. The answer for 41 is C, right? And C is corresponding to metal Y. And for 42, says in which of the following pairs of metal is the first metal most likely to displace the second metal? For A, we have XY, B, Z, and C, B, Z. All right. So again, in which of the following pairs are so they want to know, right? In which of these pairs will the first one displace the second one? So which one is more reactive? Right. So remember, all of these are metals, and based on the reactivity series, we know that the more reactive metal will displace the, the lesser reactive one. All right. So for X, X reacts with steam but not with cold water. Y reacts rapidly with cold water. Y is more reactive than X. Therefore, X cannot displace Y. Remember, the more reactive one displaces the one that is less reactive. X is less reactive than Y, so it cannot displace Y. 42 with Z and X, Z reacts slowly with cold water, but X reacts with steam but not cold water. That means Z is more reactive than X. Z reacts with cold water, X does not. So Z is more reactive than X. So the answer here is B. So for 42, the answer is B. ZX. 43. It says which of the following molecules could be obtained by the cracking of octane? Remember, octane is C8H18. C2H4, C6H. This is not octane, this is octane. I could be the reverse, you could get C2H6 and C6 must get an alkene and an alkane, a smaller alkene and a smaller alkane. And they must add up to what you started out with. Now the answer is given. So we have the options, right? So for one, we have C2H4, and for compound 2, it is C6H14. And for compound 3, it is C16H14. I'm just going to skip to the answer. So the answer is 1 and 2. C2H4 and C6H14. This is an alkene, this is an alkane. If you add them up, you get back C8H18. So the answer is 1 and 2. Ethene and hexane. So if you grab octane, you can get ethene and hexane, which is what they have here. So number 43 is B as in boy. 44 says, which of the following processes produces a gas which is different from the other processes? So for A, we have respiration, which produces CO2. Photosynthesis produces oxygen. So photosynthesis uses carbon dioxide, but it produces oxygen. So for A, respiration in animals, cellular respiration produces oxygen, produces CO2. B, photosynthesis produces oxygen. C, heating calcium carbonate produces CO2. D, oxidation of carbon monoxide produces CO2. So the answer is B, photosynthesis. It is the only one that is producing oxygen. The rest of the processes are producing carbon dioxide. So for 44, the answer is B as in boy, oxygen. For 45, we have butene. So butene and reactive BR2. What should be the correct number? Wherever you have the double bond, you're going to break it, double bond. So wherever you have the double bond, you're going to break it. So and then one each goes to the carbon and the double bond. Right? So if you have butene with the bromine, this is what you will get. Right? So that is the correct structure. So 45, it says, what is the correct structure? What is the correct structural formula of X when Br2 reacts with butene? So this is the correct structure. And the answer corresponding to that is D as in dog. So this is the structure. All right, 46 says, which of the following compounds contain a saturated hydrocarbon? The answer is A, natural gas. Natural gas is methane. CH4, that's an alkane. Alkane are saturated compounds. So 46 is A, natural gas. And this is how many isomers of butane are there. Butane C4H10, it has 2 isomers. The straight chain form, which is butane, and 2-methyl propane. So the isomers of butane C4H10, how many isomers? We have 2 isomers. The straight chain and the branch 2-methyl propane. Right, so that was 47, B, 2 isomers. 48 shows a reaction, an organic acid with alcohol. So a carboxylic acid with alcohol to give an ester plus water. So we know that is esterification. So when alcohol reacts with carboxylic acid, which in this case they refer to it as organic acid, that reaction is esterification. Esterification, you are producing an ester. The answer is C. So 48 is C. 49 says, so we get a list of metals, and it says which metal reacts vigorously with water to produce a strongly alkaline solution. Reacts vigorously, it must come from group 1. The options are aluminum, copper, iron, and sodium. Sodium is from group 1, very reactive metal. So the answer is D. 49, D as in dog, sodium. All right, if with sodium will react with water to give sodium hydroxide and hydrogen gas. All right, so 49 is D. Then it says which metal as an alloy which is used in the manufacture of aircraft. So 50, which metal as an alloy which is used in the manufacture of aircraft? The answer is aluminum, and the alloy is duraluminum. 50 is A, aluminum. 51, which of the following substance is soluble in water? A, we have propanol. B, we have ethene, right? C, we have propane, and D, we have an ester. Alcohol is soluble in water. So the answer would be A. So alcohols are soluble in water. Alright? So the answer would be propanol. Yeah, alkane and the alkene, those are not soluble. Either is their ester. 51 is A. 52, which of the following substances an important constituent of chlorophyll? Magnesium is the answer. So 52 is D. So an important constituent of chlorophyll, magnesium. 53, a suitable joint agent for the laboratory preparation of ammonia gas, calcium oxide. So 53, A, calcium oxide. 54, it says which of the following phrases correctly describe the compound shown? So they gave us an alcohol. So we have the compound with the OH group, and we know OH is the functional group for alcohols. So for 54, it says A, an alkene, B, an alcohol, C, a branch alkane, and D, non-reactive with sodium. The answer is B as in boy, an alcohol. So 54 is B. 55, which of the following observation is expected when silver nitrate is added to potassium chloride? When silver nitrate is added to potassium chloride, so silver nitrate, H3, reacts with potassium chloride, this is a double displacement reaction. We are going to get silver chloride, which is insoluble, and silver chloride is a white precipitate. So we have silver nitrate with potassium chloride, so we get silver chloride and potassium nitrate. Silver chloride is a white precipitate. If it was silver bromide, so if it was potassium bromide, you would have gotten silver bromide, which is a cream precipitate. If it was potassium iodide, you would have gotten a silver iodide, and the precipitate would have been yellow. So the chloride gives you the white precipitate, bromide cream precipitate, and iodide a yellow precipitate. All right, so for 55, the answer is C, a white precipitate appears. So 55 is C. 56, it says a polyamide is formed by a condensation reaction between a molecule containing, all right, the answers, the polyamide, it formed between a molecule containing at least one carboxyl group and another containing at least one amine group. So the answer is A. It must contain a carboxyl group, which is COOH, and the next molecule that has at least one NH2 group, right? So for 56, it is your polyamide formed from one molecule that has a COOH group, and the next molecule containing at least one NH2 group. So 56 is A. 57, which of the following features is not true of all homologous series of compounds? A says, so the members of a homologous series of A, the same functional group, that is correct. B, the same general formula, that is correct. C, similar chemical properties, that is correct. D says the same empirical formula, that is not correct. And it asks which of the following is not true. D is not true. They don't have the same empirical formula, right? So that's the answer. 58 says, which of the following substances can be produced directly from ethanol? Option 1 is ethene, option 2 is ethane, option 3 is ethyl ethanol. Of course, we know we can get ethene from alcohol because of, if you dehydrate the alcohol, you get the ethene. You react the alcohol with a carboxylic acid, and you get the ester. So the answer is 1 and 3. The ethene, so the alkene, and the ester. All right, so ethanol, you can get ethene and ethyl ethanol. So the answer is 1 and 3, which is B as in boy. All right, so B as in boy, ethene and ethyl ethanol. 59, which of the following statements is true? I'm just going to read the answer. The particles in a gas are, so A said the particles in a gas are larger when heated. No. The particles in a gas are further apart when heated, that is correct. The particles in a gas are very closely packed together, that is not correct. The particles in a gas have strong forces of attraction between them, that is not correct. So 59 is B as in boy. The particles in a gas are further apart when heated. C, C gives us a graph with boiling point and number of carbon atoms. So this is the final question. It says, which of the following molecular formula represents the alcohol whose boiling point is 160 degrees? So on this axis, we have the boiling point in degrees Celsius. Down here, we have the number of carbon atoms. So, 6, 7, instead of 100, so, if you see in this question, what you have to do is find whatever boiling point they give you, find it on the y-axis, all right? So there said 160 degrees Celsius. 160, you would read it out. All right, it's supposed to match up with 6 carbon atoms. Let me jump there. They say that, let's read it again. Which of the following molecular formula represent the alcohol whose boiling point is 160? You are going to find 160 degrees Celsius on the y-axis, right? Just draw a line to the line on the graph. Wherever it touches the line that's drawn, we are going to bring it down to the x-axis. It will match up with a number. Whichever number it matches up with, that's the amount of carbon in the compound. In this case, when you do it, it matches up to carbon number 6. Now, there are two of these graphs. Do not spot the answers. One of them is not 6 carbons. I think one of them is 7 carbons or 5 carbons. But you have two of these graphs. All right. So just when you get it, do not just go ahead and circle the answer with 6 carbons. All right. Ensure you check to see if there's 6 carbons because there is more than one graph, just like this one. There's two of them, and you may get a different one. It will look the same, but ensure whatever boiling point they give you, just match it up correctly. Don't just think it's the same question that you're seeing. All right. So in this case, it matches up with 6 carbons, and so the formula would be CH3 CH2 5OH. So now because this is 6, means that you are going to see 6 here. Remember, you have a C here. So in bracket, CH2 outside bracket you have 5. So you have 5 CH2 plus 5 carbons plus this CH3, that's a total of 6 carbons. So you read out the graph, your carbon, your alpha, it has 6 carbons. This is the formula that you will get. Alright? 5 CH2 group, that's 5 carbons. Plus this one here makes 6. So do not choose the answer where you see CH2, 6. Because I'm going to this 6 plus 1, which would make a total of 7. So it is 1 carbon plus 5 more. That would be a total of 6 carbons. All right, so in this case, the answer is C. So number 60 is C. And that is it for the 2020 paper. So that is where we close this. If you have any questions, you can send an email or leave it in the comment section.